Europe, the building industry is one of the largest consumers of natural resources. Today, the renovation of a building produces a large quantity of construction and demolition waste. This waste ends up in landfills without any form of recovery or reuse. Around 1 billion tons of waste are generated in Europe every year. Moreover, the buildings are responsible for more than 40% of European energy consumption. The main aim of InnoWEE project is the development of a new economically viable, flexible and modular solution, able to process high amounts of construction and demolition waste. At the same time, our aim is to reach a high performance in terms of energy efficiency and environmental impact. The Horizon 2020 InnoWEE project reached this goal through the creation of 3 types of prefabricated geopolymeric panels, including different construction and demolition waste for outdoor and indoor applications. The first one is wall insulating panels, the second type is ventilated facade panels, the third one are radiant heating and cooling panels. The InnoWEE consortium is composed by 10 partners, specialists in different disciplines. We have 6 European countries involved: Italy, Romania, Spain, Slovenia, Greece and Poland. So Europe is geographically well represented. In InnoWEE consortium we have 60% of industry and also the research institutions are well represented.
Our company has been working for more than 50 years in construction waste recycling, and every day we have to face the problem of disposal and reuse of demolition wastes. With the InnoWEE project, we have studied and developed a new way to convert the waste into secondary raw materials ready for the market. The secondary raw materials we provide to the other partners of the InnoWEE is the final step of a long process that certifies the quality of the material. We separate the different types and fractions of demolished material and sort them by type: wood, concrete, fire clay, glass. The materials are then delivered to the plant already selected and ready to be processed. The materials are firstly reduced by geocrushers, cleaned by unwanted materials like metals, plastic, electrical cables, and then divided by a screen into 3 categories by size. The fraction from 50 to 70 millimeters is fed into the mill, and the output, with sizes between 0 and 70 millimeters, is analyzed and marketed. This solution allows the reuse of demolished material for various destinations. To obtain secondary raw materials suitable for InnoWEE, we have to modify the wall layout of the plant and to add a new mill. We have produced a new fraction from 30 to 60 millimeters that is then brought to the new mill to reduce its size from 0 up to 2 millimeters. The hammers can be adjusted to the desired target size.
Geopolymers are cementitious materials that do not require the presence of ordinary Portland cement to harden or gain strength, and are low CO2 emission materials. Geopolymer materials seem in fact to be suitable for the substitution of traditional building materials because of their greater durability and capacity to use many wastes and byproducts as raw materials. Compared to concrete, geopolymers are more tolerant to waste aggregates, both inorganic and wood. Even geopolymer waste can be used, closing the loop. We carried out all the chemical, physical and mechanical tests required to measure the performance of geopolymer materials and products, including durability in aggressive environments. We proved their suitability for their intended use and ensured that they are compliant also from a health and safety standpoint.
It was not easy to obtain geopolymer formulation suitable for the upscale production on a pilot plant. We had to keep fluidity and long enough workability time while simultaneously guaranteeing a good quality of panels. We had to make several variations to the recipe. testing materials properties and at the same time producing a large number of prototype panels. We also had to optimize the design and test the effect of variation on real-scale products.
Inside this thermal chamber, the panels are tested according to the current standards to define their thermal performance. The InnoWEE radiant panels, thanks to the higher thermal conductivity of the geopolymeric layer, have a better thermal output than the traditional plasterboard-based solutions.
In AM Solutions facilities, there exists the technology upscaling pilot plant, the TUP, following the most strict and advanced industrial standards and under a fully automated monitoring processes. Through AM Solutions' participation in the InnoWEE project, the company faced the challenge to utilize the TUP for the production of around 400 HTG panels for the building's retrofitting. The modified pilot line involves many steps like preparation of raw materials, pre-mixing, casting, post-curing, painting, logistics, etc. From the InnoWEE project, AM Solutions gained high-level experience and expertise in designing and implementing upscaling processes for the demanding production of the high-density geopolymers.
The building of the City Hall of Vouliagmeni is an historical landmark for the municipality of Varivula Vouliagmeni as a typical post-World War II modern architecture building. Elements such as curved upward roof finishing and concrete shading frames are typical for a modern building those years. At the outside, the finishing is apparent concrete, lively colored, and rough rustic plaster. Cooperation between research institutes, small and medium enterprises, and public administration is very important for providing innovative energy-efficient solutions and implementing them for reducing building energy and minimizing environmental impacts. In our demo site building, external thermal insulation composite systems known as ETICS and also ventilated facade panels were installed.
In this demo pilot building, we have installed all the InnoWEE solutions. On the north wall, we installed the wall insulating panels. These modular elements come ready to install and do not need any further finishing intervention thanks to the geopolymeric external layer. On the south wall, we installed the ventilated facade panels. The strength of the geopolymer material makes them compatible with the standard anchoring system, guaranteeing a safe installation. Inside this room, we install the radiant heating and cooling panels. The low weight and modularity allow an easy installation. The geopolymer finishing layer ensures an homogeneous temperature distribution, providing a better thermal comfort.
At the pilot demo site in Padova, we measured the energy consumption, both for heating and cooling, before and after the installation of the InnoWEE solutions. The continuous monitoring of the demo site in Padova is assessing the effectiveness and the durability of the InnoWEE panels. The thermal performance measured in laboratory is verified in the real installation.
We have monitored the transmittance of the walls, the energy consumption, thermohygrometric condition of the room, comfort conditions, temperature and air velocity of the cavity of the ventilated facade. Infrared camera campaigns were performed and weather stations in each demo site were installed. All was monitored before and after the installation of InnoWEE panels. The panels have been installed starting from October 2018 until July 2020. We have validated all of them for more than 1 year of monitoring and testing in real condition operations. The analysis of the data of monitoring system and the several tests on the superficial condition of the panels in real conditions confirm the performance measured in laboratories. The good performance of panels produced during InnoWEE project demonstrates that these ecological panels can replace the commercial ones.
Panels were tested following procedures defined in ATAC 004 and also some additional modified durability tests method proposed by RILEM technical committees. We have tested water vapor permeability, capillary water absorption, resistance to carbonation, sulfate resistance, potential alkali-silica reactivity, and freeze-thaw resistance. And all these tests have confirmed very good performance, comparable or even better than some cement-based products. And they have proven that panels are suitable for the intended use foreseen in the project InnoWEE.
The results of the life cycle assessment, being in the environmental LCA or economic LCCA for the InnoWEE panels, were done based on monitored data in the pilot production. The analysis, taking into account realistic upscaling, shows potential of new products with a bit lower overall environmental footprint and particularly good in resource preservation part that is found in most competitive products today. Also cost-wise, the optimized products will be competitive on the market, offering better price-performance ratio. Based on the analysis, I'm quite confident the new products will at significant produced quantities provide an added value on the market, in particular because of favorite environmental footprint and resource preservation.
The project successfully investigated a recycling pathway for inorganic construction and demolition waste with a greater added value achieved thanks to the optimization of innovative binder based on the geopolymer technology. This technology offers a greener alternative to Portland cement. In addition, by means of laboratory tests, on-site monitoring and numerical simulations, the developed panels help in improving the energy efficiency of building, which was another main object of the project InnoWEE, in the framework of sustainability and green economy. Our products have a low environmental impact, a low embodied energy, a low CO2 emissions and a high thermal performance.
By the end, we identified 10 key exploitable results of the InnoWEE project. They are the results bringing innovativeness to the current market and which have the real potential to be commercialized. Among them there are 4 products, which are the main products of the project. There are 3 types of geopolymeric panels and the pilot plant for production of the InnoWEE secondary raw materials. Based on the final list of key exploitable results, a market analysis has been performed looking for a similar solution to define the results' innovativeness. For some of them, owner-partner decided to apply for patent protection. There are some results which are ready for the market, and it is on the owner to decide what to do and when to enter the market. Although the geopolymers panels are more competitive as compared to similar products in the market, they are still at too low technology readiness level for market introduction. Further tests and demonstrations are needed to reach minimum level 9 for obtaining the CE mark needed for international commercialization. There are still some barriers to overcome before the panels will enter the market. One of them is too low level of readiness. More testing is needed, however, this is also a field for another project proposal. Another and the main barrier identified during the project is related to the standardization. Currently, there are not European technical documents or harmonized standards defining how to assess geopolymer-based products. So a great effort should be made to obtain the European technical assessment and thus the CE mark.
Generally, the tendency of knowing buildings' environmental footprint is growing in the EU. However, this is only possible if the data for products as such is available. Because geopolymer products are not yet widely present in the market, there is lack of LCA data for these materials. The consequence may also be hesitation in use of these materials in real buildings, which ultimately slows the penetration of recycled materials in construction industry.
There is no European standards available for geopolymer or alkali activated building materials, but the producer can apply for European technical assessment, which is based on European technical documents developed by EOTA. And this will be a tailor-made document which will enable the producer to adequately test the new innovative products and assess performance for intended use.
In these 4 years of research in InnoWEE project, 10 partners from 6 European countries shared their expertise to contribute to the project's success. They designed, produced, and finally installed and tested these innovative panels in different buildings, also historical, and in different climates. Obtaining this promising result would not be possible without the contribution of the European Union. The outcomes prove that a collaborative and well-matched consortium can achieve challenging goals despite the numerous difficulties that always affect such research and innovation activities.